You will find this material in Chapter 5 of Introduction to Macroeconomics by Paul Middleditch. In today's lecture, we're going to look at two different approaches to modelling the labour market: a static view of the labour market and a more dynamic approach that looks at labour market flows. We'll then go on to the topic of unemployment before marrying together two important macroeconomic variables, inflation and unemployment, in the Phillips curve. We begin with the static view of the labour market, which is a simple two-dimensional analysis between the supply of labour and the demand for labour. Static in that there's no dynamics or no allowance for changes over time. We take this opportunity to remind ourselves of some important labour market measures or indicators, also variables. The working age population is the number of citizens in our society who are of working age, and that's normally between the ages of 16 and 65. The labour force are the proportion of the working age population that are participating in the labour market. In other words, the proportion of the working age population willing and able to work at any given wage, also known as the workforce. The participation rate, then, is the percentage of the working age population that are participating in the labour market. Another important variable in the labour market is unemployment. And of course, this also provides us with a measure or an indicator of the labour market. So to define the unemployed, this is the members of the labour force without work. An important distinction here is that if somebody leaves the labour force, even though they haven't got a job, they're not unemployed. So they're only unemployed if they're actively looking for work but without work. Then there is the unemployment rate, which is the percentage of the labour force that are unemployed. So the labour force has two parts: the employed and the unemployed. Everybody else is outside the labour force and they're not participating in the labour market. There is also something we can think of as the normal rate of unemployment, also referred to as the natural rate of unemployment. It's the level of unemployment we expect over the long term, and for the UK that might be around 5%, or the rate that exists in the absence of shocks to the economy. In our model for the labour market, there are agents that interact to determine the price of labour, which is the wage rate, and the amount of labour, which is the number of workers in the economy with jobs. There are those that supply labour and those that demand labour, two agents: firms supplying labour and the households demanding labour. In fact, we can look at our circular float model and see that the lower part of the model, the interaction of households and firms, the real flow from households to firms, the labour effort, and the monetary flow equal and opposite in the form of wages or income to households from firms. We can see that this proportion of the flow is actually the labour market. It's a nice way to visualize it in terms of flows, but for now we're stuck with a static model. So to begin our analysis, we can start in a two-dimensional space between the real wage, W over P, and the amount of labour in the economy, L. To carry out production, firms need workers. And so our first agent is the firm that demands worker. That represents the labour demand schedule in the economy. Notice that it's downward sloping, so that the higher wages, there's less demand for labour from firms. Households are our second agent in the model, and they supply labour. Notice that it's upward sloping in real wage labour space, and that's reflecting that at higher wages there are more workers prepared to work, and more workers looking for work, more citizens participating in the labour market. Where these two agents interact, we have the real wage and the equilibrium level of labour in the economy. Now we can use the labour market to show the economic effects of a growing economy. So imagine that the economy is growing, firms will demand more labour every wage, so the labour demand schedule shifts to the right to reflect the higher level of demand at every wage rate due to the increase in economic activity. In the labour market, this has the effect of putting upward pressure on the real wage, and we see that that real wage exists at a higher level of equilibrium output now as well. So effectively, we see that for a growing economy, the level of labour in the economy will increase and unemployment will fall. One of the beauties of using the static view of the labour market is that we can show the difference between equilibrium and disequilibrium unemployment. We can explain them as two parts. Equilibrium unemployment is the unemployment that always exists. Whatever state the market is in, there is always going to be some unemployment, and that's a reality. And we can think of that as core unemployment. Then there is disequilibrium unemployment, which is unemployment caused by disequilibrium in the labour market. It might be that there is a demand efficiency in the economy, it might be a recession, so firms demand less labour, and there is unemployment caused by disequilibrium. We can show this diagrammatically, starting in real wage and labour space with the labour demand schedule downward sloping and labour supply from households upward sloping in the real wage. We can add another schedule to this diagram which represents the entire labour force. And this is the labour force that we defined earlier. And note that equilibrium unemployment is the difference in labour market equilibrium between the labour force and the level of jobs provided by firms' labour demand. This here is forced unemployment, if you like, or involuntary unemployment. Even though people are prepared to work at the equilibrium wage, there is still some level of unemployment in the economy. Types of equilibrium unemployment. There will always be some unemployment due to the friction in the labour market. So while people are looking for jobs, depending on how difficult it is to get jobs, there'll be a certain level of people in between jobs, so that we call frictional unemployment. Then there is structural unemployment that exists at all states of the market, and that might be due to changing patterns of demand. It might be that a seaside town has suddenly become less favourable to holidaymakers. It could be regional unemployment, unemployment caused by closing down of industries, and there might be technological unemployment. That's unemployment caused by the introduction of new technologies, and we see that more and more with the robots being introduced into the workplace. Then there is also seasonal unemployment. That unemployment was caused naturally by the seasons, for instance ice cream sellers in the winter. Now we can show disequilibrium unemployment. We begin with the labour market, and this time with the addition of the labour force schedule, and imagine a real wage or a state of the economy where the real wage is away from its equilibrium level, and that might be something we think of as the minimum wage. At the minimum wage here, there is not only a difference between the labour supply schedule and the labour force schedule, there is also a difference between labour demand now and labour supply schedule. And this element of unemployment here, caused by the movement of supply or demand in labour, is called disequilibrium unemployment. So we can think of unemployment caused by a recession as disequilibrium unemployment, And unemployment tends to exist naturally in the labour market as equilibrium unemployment. We now look at a dynamic approach of the labour market, and this dynamics allow us to look at the labour market in a more detailed way to see what underlies the movements of the variables like unemployment. So we're going to do this by capturing the flows in and out of the labour market. Now we're ready to discuss the components and the flows of the labour market. What are the components? Well, the components are, as we've discussed before, parts of the labour market. So for instance, one part is the working age population, another inside that part is the labour force, and inside the labour force there is the pool of unemployed. The labour force minus the pool of unemployed is the pool of employed. Then there are flows in between the components. For instance, a hire is getting a job. So we move through the flow from the unemployed to the employed inside the labour force. A fire is a flow in the opposite direction. An exit is a worker leaving the labour force altogether. And an entry is somebody joining the labour force, maybe from the working age, a flow from the working age population into the labour force. How can we picture this? Well, here we have a diagram that enables us to understand the flows between the components. And we can see here the two periods, this is period 1 and this is period 2, that the working age population is static, it hasn't changed. But we can also see that the workforce, which is inside the working age population, has changed. See, this circle has become smaller, so the workforce has shrunk. We can also see that the pool of unemployed which exists inside the workforce has also shrunk from period 1 to period 2. Now, under our static model, we could just declare that unemployment has fallen. But is that really the case? What has actually happened here is that the workers have moved from the pool of unemployment in period 1 to outside the labour force. In other words, they've given up looking for work, and it's possible that employment from period 1 to period 2 has not changed at all. So when we look at the flows, on the surface we see a movement in unemployment, but what is actually going on is that people are leaving the workforce altogether. So it's not a better outcome to have lower unemployment if your workforce is also shrinking at the same time. And looking at the flows, we can analyse this better. One benefit of the flow approach to the labour market also allows us to have other measures of the condition of the labour market, and one such measure might be the duration of unemployment. Somebody has been unemployed for a long time, or if a good section of your pool of the unemployed have been unemployed for a long time, this is a negative indicator of the fluidity of the labour market. How do we measure unemployment durations? Well, luckily we can do that with our probabilities of our variables hire and fire. Unemployment duration is equal to the inverse, it's 1 over the probability of a worker being hired or exiting the labour force altogether. So you leave unemployment if you are hired, or you exit. And this gives you unemployment duration, which is another interesting measure. It goes deeper than the level of unemployment in the economy. This is the normal measure that we get from the media. Here we have some data. It's interesting for the UK. Between 1992 and 2015, the percentage of unemployed workers without work for more than 1 year, and this is a dangerous period of time because it's possible that someone will start to give up looking for work. So we have something called hysteresis, and we have people exiting the labour force, which is not necessarily good for the economy. And we can see since the 90s that this has been reduced, the level of long-term unemployed, but that this actually increased during the financial crisis, which is maybe we might expect. However, more recently there's been a sharp drop in the percentage of unemployed without work for more than 1 year, and that might be for all kinds of reasons. It might even be for other labour market policies, policies to do with claimants or benefits, and we've seen the introduction of universal credit. Maybe this has had something to do with this unemployment duration in the UK. So how do we compare the two approaches? With the static approach, the benefit is that it's quite simple. It's a simple two-dimensional diagram, and we can explain the difference between equilibrium and disequilibrium unemployment. So even this simple model has an explanation for the fact that unemployment exists at all times. The flow approach, however, allows us to go deeper to understanding the driving forces behind the changes in the level of unemployment. We see unemployment changing in the news, and we might say that unemployment is a 40-year low currently. But is that really a good thing, or is that something that's actually reflecting another problem in the labour market, such as hysteresis or people exiting the labour market altogether? We now go on to discuss inflation, which is the change in prices, in more detail as we approach a model for the Phillips curve, which gives us a relationship between inflation and unemployment. We start with defining inflation. To define inflation, we first need to discuss what is the aggregate price. And to do that, we need to talk about what is the price. What is a price? The price of a good is just the nominal value for which it is sold. It's the ticket we see on goods. But in macroeconomics, the aggregate price is the average price in the economy, or the price level. We can also think of it as the price level. P on our axis. Inflation, then, is when the price level is increasing. If prices change, that change is called inflation. It's the difference between price in one period and price in the previous period. But how is the price itself determined? So we know that inflation is determined by changes in the price. How does price change? How does a price change? Well, it changes because of market fundamentals. And we've already begun to understand that when labour supply or labour demand change, that changes the equilibrium wage. And in a similar way, when there are market fundamentals in the economy, changes in aggregate demand or aggregates of supply, there's going to be a change in the prices. Well, we understand that. But is that all that drives the price? Well, no. Also, our expectations drive prices. So it might be that there's a shortage of a good, that will drive the price up. That's a market fundamental. But if we're also expecting the price to increase, it's more likely that there will be a price increase. We can think of expectations as self-fulfilling. Just by expecting a price to rise, it can cause a rise in the market, as there's a sudden increase in demand. So the price of X is driven by the market fundamentals, is what we expect, plus the expected price of good X. Now we can work with this and write this relationship in the previous slide in terms of the aggregates. We can say that the aggregate price P is driven by the aggregate market fundamentals excess supply in the economy or excess demand in the economy, plus the expected price level. So if we expect prices to rise, then they will. We can subtract the previous period's price from both sides and then rewrite this in terms of inflation. So we know that P minus 1, so the difference between the price and the price in the previous period, is actually inflation. So we can write that inflation is equal to market, or driven by market fundamentals and driven by the expectations of inflation. So the central bank have two drivers for inflation to work with. We end up with a policy trade-off. We can say that inflation is equal to expected inflation plus market fundamentals. This gives the policymaker or the central bank a choice. If it wants to get inflation down, then it can either change people's expectations of inflation, or it can change the market fundamentals in the economy. It could cause a recession in order to get prices down. So we have a trade-off between the two drivers for inflation. What this is essentially saying is possible to get inflation down just by manipulating people's expectation of inflation, which is a bizarre concept, but accurate, and we'll discuss in the lecture how this is possible. Another way to think of inflation is using the Keynesian cross. We can use this by using a deflationary or inflationary gap. So if equilibrium output is below full employment output, in other words, if we are in a recession, we can say there is a deflationary gap. That gap is given as the amount that national income exceeds aggregate expenditure. In other words, how much actual output exceeds aggregate demand. In a similar way, if we are in a boom and output is above full employment output, then there is an inflationary gap. This is probably best seen in the diagrams that follow. In the case of the deflationary gap, we begin with the Keynesian cross, where the expenditure line crosses the equilibrium condition y is equal to E. This intersection gives us equilibrium output, YE. Now imagine a scenario where the equilibrium is below capacity. Then we can say that at capacity, at YF, there is a gap. And that gap is given by the distance AB, which is the deficiency of demand, or the amount that expenditure is below actual output. This is known as the deflationary gap. In the case of the inflationary gap, again we begin with the Keynesian cross, but this time imagine that full employment output is below equilibrium output. So the equilibrium is above capacity. Therefore there will be inflation, prices will rise because quantities cannot, and the inflationary gap will be given as the distance between E and F, or for which demand E is greater than actual output at F. That's the inflationary gap. We now discuss a relationship between inflation and unemployment called the Phillips curve. In 1958, an economist called William Phillips was carrying out an empirical study between wage inflation, the rate at which wages rise, and unemployment. He noticed a negative relationship in the data. This suggested an economic model, supply-side model, gave or implied a trade-off between price stability and unemployment. We could have high inflation and low unemployment, or we could have low inflation and high unemployment, which is intuitive. We can look at this relationship both mathematically and graphically. Mathematically, we could write that inflation pi t, remember inflation is pi here, so inflation at time t is equal to inflation in the previous period, so there's a correlation between periods for inflation, minus some sensitivity beta of level of unemployment. And that will be matched, these two, by an economic shock. The difference between the left-hand side and the right-hand side is covered by the shock, which is the explanation between the model and the data. To draw the Phillips curve as a downward slope function, showing us that unemployment is downward sloping in the inflation rate. High inflation will be low unemployment, low inflation, high unemployment. So there's a trade-off. The policymaker can actually use this as a tool, a policy-making tool. If inflation is too high, we simply need to increase unemployment to get inflation under control. How will we do that? We'll increase the interest rates, reduce the money supply, increase unemployment, dampen economic activity, and reduce the possibility of any further price rises. Get inflation under control. However, a rather blunt instrument to use. The slope of the Phillips curve is beta here. It's the sensitivity of inflation to changes in unemployment. So this curve offered policymakers a menu or a policy-making tool which held in the 1960s because of the data that William Phillips used. However, the relationship broke down in the 1970s, even though it was still being used for policy in the 1980s. In the 1970s, we saw high unemployment and high inflation simultaneously, which implies a positive relationship. Let's look at the data, the observations, outcomes from inflation and unemployment for the year in the UK. You see during the 60s that one could claim that there was a downward sloping relationship between inflation and unemployment. However, if you look at two other cases, this one particular here, you see in the late 70s and early 80s, this appears to have become upward sloping. Or in the noughties, we could have any level of unemployment at a low inflation rate. So the relationship itself had broken down, at least in its current form. So how do we get around this problem of the inconsistency across the decades? Well, Milton Friedman came up with a natural rate hypothesis that allowed, and we have done this in terms of aggregate supply, that allowed a long-run Phillips curve and a short-run observation away from that long run. So now we can explain almost any observation by the combination of a long-run element in unemployment and a short-run element. So we can separate the Phillips curve, and we call this the expectations augmented Phillips curve, that allows now for expected inflation rather than inflation in the previous period. Now we replace pi t minus 1 with e pi t, expected inflation. It's the expectations augmented Phillips curve. We also replace ut with the unemployment gap. So just as before, we have the short run now, Phillips curve, downward sloping with slope alpha, downward sloping in the inflation rate. We can explain any short run observation on this graph by the short run Phillips curve shifting left and right. Add to that Friedman's explanation of the natural rate so that the long run Phillips curve is now vertical, and any observation between inflation and unemployment can be explained by a combination of the long run value of unemployment plus the short run deviation from the long run. So wherever the observation, we can just simply shift this short run Phillips curve left or right to explain it. It managed to explain the inconsistencies in the data. Bear in mind that when inflation is at its expected level, the short run and the long run Phillips curves cross. But we are at U star, the natural rate of unemployment. Aside from being able to better explain the data, we now have a Phillips curve that can give us some monetary policy analysis. So we'll start off by using an increase in aggregate demand and see how that affects unemployment, and then inflation to see the short run and long run effect of expansionary monetary policy. So we begin with our expectations augmented Phillips curve, where the long run Phillips curve and the short run Phillips curve coincide. We have the natural rate of unemployment U star and the expected rate of inflation IE. The central bank wants to reduce unemployment, so increases the money supply. Effectively, it has created inflation but has managed to get unemployment down. So the inflationary surprise has increased economic activity. However, by increasing inflation, we've also now increased expected inflation. Essentially, what has happened is that the short run Phillips curve shifts right, so that where it crosses the long run Phillips curve is now at the new level of inflation, which is the new level of expected inflation. All that the central bank has achieved is a short run deviation in unemployment, but a long run increase in inflation.